one, you had to solve this by substitution. So with your substitution process, you need to get one of your variables by itself if it's not already. The easiest one to do that is the y in the first equation. Get everything away from that by subtracting. So y equals negative 3x plus 5. Take that equation, put it into your other one, where y is. So you substituted the equation into the other, and then start to solve for the variable. So distribute. And then solve for x. So I'm going to combine these and move this at the same time. This one should have an x. And then divide both sides by negative 17. After you find what x is, take that, put it back into one of the equations, doesn't matter which one, just find y. So y equals negative 3 plus 5, or y equals 2. So that solution, that order pair would be 1, 2. What questions, confusion do we have on that one? For the next one, we had to solve by graphing. So take both of these and graph them on here. So the first one, we're going to start at 5. Our slope is negative, so we're going up 1 to the left 2 as many times as possible. Down 1 to the right 2 as many times as possible. And connecting all of your dots. Be careful with your other one because this is not in slope-intercept form. So if you want to rewrite it, you can do that. But we should be starting at positive 7, and our slope is negative 1 over 1. And then you would find where these intersect. And that would be at the point 4, 3. And that would be your answer. Questions on that one? And then the last one, your elimination. You have to have common coefficients. Right now you don't. It doesn't matter which one you solve for or eliminate first. I got rid of my x's. Some of you may have gotten rid of y. It doesn't matter. As long as you come out to the same answer at the end. So I made our x's both 12. So multiply the first one by 3 and the second one by 2. So we have 12x plus 15y equals 18. And 12x minus 14y equals negative 40. To eliminate the x's, we would need to subtract. 15 minus a negative 14 would give us a positive 29y because you're really adding. And then same thing here, 18 minus a negative, you're really adding, so it's going to give us a positive 58. And then divide both sides. Once you find that y, put it back into one of your equations, doesn't matter which one. So let's say I choose the first one. And start solving it for x. So we end up with x equals -1. So -1, 2 would be our final answer. Do we have any questions on that one? Today, we're going to talk about word problems. Everyone should have this packet in front of them. There are a couple things nice about these word problems. One, there are only 3 ways to solve them: graphing, substitution, or elimination. So the how, we already know how to do. It's just setting it up. So read this one with me, either on your paper or on the board. A snack bar sells large and small nachos. Large nachos cost $5 and a small pack of nachos cost $3. In one day, the snack bar sold 60 packs of nachos for a total of 220. Let L be the number of large nachos and S be the number of small nachos. Write a system of equations to model the situation and determine how many large and small packs of nachos were sold. So of all that, what do you find important?
Large nachos cost $5.
Okay. What else?
A small bag of nachos cost $3.
Okay. Josie. Anything else?
L large nachos and S small nachos.
In general, all numbers you see are important. So then we would start off with defining our variables. So last time we did word problems, you had to define each variable. This time you only need to define 2. The 2 things you don't know. So here they gave us our 2 variables, but if they didn't, we would look at the question. How many large and small packs of nachos were sold? That would tell us what we don't know. So we would write that as our variable. But since they told us, we're going to use those variables. But notice that they match. L is the number of large packs of nachos, and S is the number of small packs of nachos. The question and the variables match. So when we define our own variables, it has to be that specific. So number of large nachos. Because if you just put S equals nachos, I have no idea what that means. What don't we know about the nachos? Be specific. After we find our variables, we can use that to start writing our equations. When we did word problems last time, there was one type where we were comparing 2 different things, and I said that you always use the ax plus by equals c. For all of these, because we're comparing two different things, this will be the format of almost all of our equations. Instead of x and y, we're going to use our variables that they gave us, L and S. And as I said before, your A and B are usually given. So if you look here, your A and B are given, the 5 and the 3. How do we think we would write that into an equation? Using the A and the B from up here, the L and the S, and then some C. Josie? So the total here, the 220, it really gave you two different totals, the 60 and the 220. So in order to know which one goes where, you have to look at the numbers it gave you. The 5 and the 3 both represent cost. The 220 is talking about cost. So all of the cost things need to go together. Now, because it is a system, we need two equations, not just one. We cannot use any of these numbers again in our second equation. They did give us that 60. That is a different total. That is the total of number of packs in general. What else represents something about number of packs of nachos?
L and S.
Mm-hmm. So because L and S represent what this is talking about, those are the two things that are going to be added together here. So sometimes your variables will have numbers, sometimes they won't. But it's still in that AX plus BY equals C format. Okay. Questions so far? We are going to solve this one by graphing. So if you don't have your calculator, go grab that. Your calculator does not like other variables other than x and y, so we have to change the variables we use to x and to y. Does not matter which one you make x, which one you make y, as long as you're consistent. If you make L x, all of the L's have to be x. And vice versa. And we need to get both of these equations in y equals format. So the second one is pretty easy because we could just subtract the x to both sides. The first one, however, we will need to solve. So I'm going to rewrite that over here. So we would get y by itself by moving the x term, just like the other problem. Subtract 5x. Divide everything by 3. These are both going to give me fractions, so I'm just going to leave them both as fractions. And then once you have both equations, we're going to put this into our calculator and graph. To go into y equals, and type in your two equations, 60 minus x and the 220 over 3 minus 5 over 3x. Use alpha y equals to get your fraction. Once you have your equations in your calculator, you're going to go ahead and graph it. And one of two things will happen. You'll either see the lines or you won't. Sometimes you won't, depending on the numbers you put in. 220 over 3 is a big number. So this is 10 by 10. So we need to zoom out or zoom something to fit it. So I'm going to go into zoom, scroll all the way down to 0. Look for zoom fit. Now I can at least see the lines, but they're not crossing. If they're not crossing, this next part won't work. Negative instead of minus. Keep going down. Graph. Okay, so after you graph it, zoom fit, and then here my lines aren't crossing, so I need to zoom out again because they are going to cross somewhere over here. It's just not in this window. I'm going to zoom again, but zoom out. So after you hit zoom out, you have to hit enter. If you don't see them crossing, raise your hand. One of your equations is graphed wrong. This one. Double check that in the y equals. Anyone else's lines not crossed? Double check your numbers. Okay. So then to find our intersection point, we're going to go into second trace, intersect, and then enter 3 times. Their y is already there. So if you miss that, second trace, intersect, enter 3 times. And it'll tell you what that intersection point is, because I couldn't count this. There's way too many things going on. So you would write that down, but if your original variables weren't x and y, I don't know what that means. So you would need to put those back as your original. X was L, that means L is 20 large packs. Y was S. So S is 40 small packs. And the rest of the work, you would just say you graphed it. So if the graphing method confuses you, there are two other ways to solve all of these by substitution or elimination. Most word problems can be solved by elimination. Some will be solved by substitution, and then you could do them all with all of them. Do we have any questions about this? If you're solving by graphing, you'd have to use the calculator though, because some of the problems are going to get too big for you to actually graph. After you have this all written, go to example 3. Start reading that. And then tell me important things you find.
E, cost of earrings, and S, cost of pair of shoes.
Okay.
5 pairs of earrings, 2 pairs of shoes for $50.
Anything else?
Each pair of shoes costs $2 more than 4 times the cost of earrings.
That entire sentence is important. Alright, so just like before, we're going to start off with the variables. Yes, they gave it to us, but if they didn't, we'd be looking at the question to determine the cost of a pair of shoes and a pair of earrings. Those would be the two things we don't know. The two things we don't know would be our variables, E and S. So cost of earrings, cost of shoes. Then we're going to write our two equations, but one of these is going to be a little different. So let's focus on this sentence in pink, highlighted in pink, magenta, whatever. Each pair of shoes costs, so everything else that it's about to say is talking about the shoes. So we can say shoes equals two more than 4 times the cost of earrings. How do you think we would write that? 2 plus 4e. But if you use x, sure. So then we have our equation for s. We still need a second equation. So everything in yellow/blue, we're going to use to write that second equation. If the format is going to be similar to the last problem we did, how would we write that? almost all of your problems are going to be set up that exact same way. The second equation, not the first. If you have an equation that has a variable solved by itself already, which method would be best to use here? Substitution. So we're going to substitute the S equation into the other one. So 5e plus 2 times 2 plus 4e equals 30. Distribute and start solving for e. And then shut this one off. Combine your like terms and subtract the 4 to the other side, which I did at the same time. What would e equal? To what? What are we looking for? E represents $2 per gram cost. Yes. Great, so we have our cost for E. We need to go back and find our cost for S. So the equation that we found at the beginning, we're going to use that equation. So S equals 2 plus 4 times 2. So S equals 10 what? $10. So make sure your answer is specific as well. If you just put 10, I don't know what that means. So some problems will be set up nicely for substitution, not many, but some. Questions on that one? Once you have all of that written down, find the maze in your notes. We're going to just do one of those. I would say probably leave your notes open like this so that you can use like this blank space to write stuff down. Read this first one. Tell me important things you see. Josie. 4 fountain drinks.
3 bags of popcorn. Page 2250. 5,000 drinks. And 2 bags of popcorn. Page 2250.
So in this problem, you're given 6 numbers. All of the numbers are going to be used. That means in your 2 equations, they'll most likely both be set up as the ax plus by, and everything will have numbers. But in the question that it's asking, that's going to tell you what you don't know. How much is a fountain drink? So So that is going to represent one of our variables. You can call it F, call it D, call it X. It does not matter. So let's say I call mine F. F would represent the cost, because that's something we don't know, the cost of the fountain drink. What else don't we know?
Cost of popcorn.
Mm-hmm. You can call that P, call it C, Y, whatever you want. Tell me who your counsel is. What is it? Okay, so now we have a bunch of numbers, we have variables. How would we set up our equations?
4F plus 3P equals 2250.
That would be one. And then how would we set up the other one? So we have our two equations. Now, this one we're going to solve by elimination. The question is asking how much is a fountain drink, so we don't really need to know the cost of popcorn in this. Because of that, we're going to solve for one of the variables specifically so that we focus on cost of fountain drink. If we were to eliminate the P's, we would be left with the F's. So we're going to do that. Multiply the first one by 2, so it becomes 6. And the second one by 3, so it also becomes 6. So we'd have 8F plus 6P equals 45. And 15F plus 6P equals, I think that's right, double check that. To eliminate our P's, what would we do? Mm-hmm. So if we're subtracting, the P's go away. 8 minus 15 will give us a negative 7. F. 45 minus 71, 25 would be negative 26, 25. Again, double check that. I'm not confident in that answer. I'm also not doing this in my head. I just remember from last class. Okay. And then divide. And what would F be? $3.75. So for the maze, I'm going to switch this for 1 second and come right back. You'll know if you got it right if it's one of the answers here. If it's not one of the answers, something's wrong. So you know which direction to go if you use that as practice. But for each of these problems, look at your answer. Ask yourself, does this make sense? If you're looking for a number of things and you get a decimal, it probably doesn't make sense. Something went wrong. If you are looking for a cost and you get something that's bigger than the numbers that are given, like let's say you get 25 when you only spent $23.75 or $22.50, something's probably wrong. So double check that. Ask yourself that. Do we have any questions on this? There are 2 more problems I want to show you, talk through, and then you'll have the rest of the class to practice. So find this page. Before we go through a couple of these, I need to explain to you some things. One, these are similar, the plane and boat or river problems. If you see something that's flying with the wind, you have to think about that as the plane is flying in wind that's not pushing against it. So the wind is helping it, the wind is pushing it, so that would be adding. If it's flying into the same wind, so the wind it was going along with is now going in the opposite direction, so you're going to be subtracting. In that same, with planes, you might see tailwind instead of those words. Tailwind means the wind is pushing the tail of the plane forward, so it's helping it again, so adding. And then again, back into the same wind against the wind would be subtracting. Then you have going down a river, we're assuming the stream is going downwards. So you'd be going faster downwards. And then going up the river, you're going against the stream, so you're going slower, so you're subtracting. And then it might say with the current or against the current, that's the same thing. So with the current is like the river is pushing it along, it's helping it, it's moving faster, so you're adding. And then against the same current, you're going in the opposite direction, you're subtracting. So you'll need to keep those things in mind if you see any of these problems. For number 1, we are flying with the wind of a plane that went 369 miles per hour, flying into the same wind that only went 325 miles per hour. We need to find the speed of the plane in still air, that just means the wind is not helping it, and the speed of the wind. So it tells us the 2 things we're looking for: speed of the plane, speed of the wind. Those are going to be your 2 variables. Call them what you would like. I'm going to use W and P to represent the wind speed and the plane speed. Flying with the wind, first, backtrack. Both of the numbers they gave you are your totals. If the plane is flying with the wind, are we adding these or subtracting them? Adding. So W plus P equals 369. And then flying into the same wind, we are subtracting. But if you're not sure which one we're subtracting, think about it like this. Is the wind helping the plane speed, or is the plane speed helping the wind speed? Yeah. So since the wind is helping the plane speed, the wind is what we need to subtract. Awesome. I'm going to switch the order of these so that they line up. These are really good elimination problems, but they can be solved by graphing or substitution, doesn't matter. If we were eliminating, which one would you want to get rid of first? P or W, does not matter. Okay. So if we're getting rid of P, what would we do to eliminate them? subtract everything, p's cancel, w minus a negative w, that would really be adding. 369 minus 325 would give us 44. Divide both sides by 2. And then your label would be whatever mileage or whatever it says, so miles per hour. Questions so far? Use W to go back and find P. So subtract if you use the first one, add if you use the second one. With all of these problems, you should be able to quickly go back and double check yourself. 347 plus 22 gives us 369. 347 minus 22 equals 325. They both work. So do that to make sure you have the right numbers, but also think about the answers. Typically, your plane speed is going to be faster than your wind speed unless there's like some natural disaster or something going on. We're assuming that's not happening. So your plane speed should be faster than your wind speed. If that's not, something's off, something's wrong. Questions on that one? For number 2, we are going down the river. The boat went 13 kilometers per hour. Going up the river, it only went 3 kilometers per hour. It's asking for the speed of the current and how fast the boat would go if there were no current. The wording is a little tricky, but just pay attention to what it's really asking. What is the speed of the current? The current is the river speed. So I'm going to call that C. Asking about the speed of the river or the speed of the current. And then how fast would the boat go if there were no current? That just means it's asking about the boat's speed. How fast is the boat really going? So we're not looking for the speed of the current when it's not moving, because that would just be 0. We're looking for the boat speed. How would we set up these two equations? It's similar to this last problem. Okay. And then what would we set equal to 13? What would we set equal to 3? B plus C for which one? For 13. And then for 3? B minus C. Because the boat speed is being helped with the river speed, so we're getting rid of the river speed. Okay, and then let's say we are getting rid of B. We would, again, subtract. B's would cancel. C minus a negative C would make 2C. 13 minus 3 would be 10. And then if we divide, be careful with your labels. Some are miles per hour, some are kilometers per hour, some might be something else.
Will the test any questions
be at least one of these. Right, and then go back and find B. Again, these are small enough that you could put them back in. 8 plus 5 is 13. 8 minus 5 is 3. Those work. And just like the last one, your boat speed should generally be faster than the river speed. Even if the boat is going slow, even if the river is going slow, the boat should still go faster. Do we have any questions on that one? For the remainder of class, you guys have a bunch of practice you could be working on. One, you have a bunch of word problems in this packet that you can go through, practice. I would say definitely try some of the boat or plane ones and then maybe some of the others. You have your review packet because your quiz is next class. Your test is Friday. So review some of the problems on the review packet. That way you remember all of the methods, bring whatever questions you have on that to class on Wednesday. And then you also have the 2 Khan Academies that are due on Friday on word problems and elimination. So you guys have a lot of practice. Use this time actively to practice.